In section 9.4, we're going to solve quadratic equations by completing the square. So what are you going to learn today? You're going to learn how to complete the square for expressions that are in the form ax plus bx. You're going to solve quadratic equations by completing the square. You're going to use this to find maximum and min points, and you're going to solve real-life problems as well. So completing the square is for use when you see an expression without a c term, x squared plus bx. Now, you can add a constant c to the expression so that x squared plus bx plus c is a perfect square trinomial. This process is called completing the square. Here's the biggest problem that I see. Students don't understand really why they're doing it or what they're doing, but once you do, it's not that hard. It's just remembering quite a few steps. So let me kind of show you what I'm talking about. As review, you should know that this problem here would be a perfect square trinomial. Here it is. Why is it a perfect square? Because anything times itself is a perfect square. If you actually took and factored this, you would get x plus 3 multiplied by x plus 3, which would give you x plus 3 squared. Therefore, it is a perfect square trinomial. But the problem is they're not going to give you this 9. They're going to give you something that looks like this, and then you're going to complete the square. And here are the steps you're going to use to do that. To complete the square, you must first find 1/2 of b, and then you square it. That's step 2. If b was 5, you'd take a half and get 2.5, and then you'd square it. If b was 8, you'd take half, which is 4, and square it. You then add that result to what you currently have, and that is how you get c. All you've done is find c. So you take half of whatever b is, and then you square it. Let's do our first example. We're going to just complete the square. That's it. Complete the square. Complete the square. So here we go. Half of b, well, that would be 6 divided by 2, and then we square it. Well, that'd be 3 squared, which is plus 9. So by completing the square, I'm just going to add a 9 to it. You then would factor, and you get x plus 3 squared. If I had x squared minus 9, I'd take half of negative 9, and I'd square it. Well, half of negative 9 is negative, will be negative 9 halves. Squared would be 81/4. So you'd leave it as 81/4. Do not get decimals. Do not get mixed numbers. Leave them as improper fractions. If you'd factor this, you would get x plus 9 halves squared. Oh, not plus. I apologize on that. It would be minus. So the next part is actually solving an equation by completing the square. Solve the equation by completing the square. Solve the equation by completing the square. Here's what we do. Pay attention. X squared minus 16, I leave a blank. I want to get this by itself, which it is, and then the negative 15's to the other side. Now, I complete the square. Half of negative 16 is negative 8. I then square that. And if I square negative 8, I get positive 64. Here is the part that people forget. Don't forget this. You can do whatever you want to either side of an equation. You can do whatever you want to any equation, as long as you do it to both sides. I just added 64 on the left side, which means I now need to add 64 on the right side. I then simplify. I get x squared minus 16x plus 64, which gives me x minus 8 squared. 64 minus 15 gives me 49. I then follow. The rules of squaring both sides, or taking the square root property. So I take the square root, I take the square root. That gives me x minus 8 equals positive and negative 7. I then add 8 to both sides, and I get 8 plus or minus 7, which gives me the two answers of 8 plus 7, which is 15, and 8 minus 7, which is 1. If I plug both of those back in to your equation to see if they worked, they would. They are both solutions. Common mistake that I see. Big common mistake, don't do this. Right here. When completing the square to solve an equation, make sure you add half squared of b to each side of the equation. And we did that right there. We added 64 to the right side. Do not forget that, ever. So now let's solve a quadratic equation that is not by itself. So, big mistake. Notice that it has to be x squared at the beginning. This is not. Here is what you do not do. You do not take half of 20 and square it. Incorrect. Here's your big error. Before you complete the square, you must make sure that this term right here, that 2, has to have a coefficient of 1. So the first thing you always do is you divide everything by 2. Everything by 2. So that gives me x squared plus 10x minus 4 equals 0. Next step, I get the minus 4 on the other side. So I have x squared plus 10x, I leave a blank, equals 4. I now complete the square. I take half of 10. Half of 10 is what? Square it. What do I get? 25. I have to add it to both sides. So now this gives me x plus 5 squared equals 29. I now take the square of both sides, square root. I get x plus 5 equals plus or minus the square root of 29. I cannot simplify the square root of 29. If you could, you'd simplify it. I now subtract 5 on both sides, and my final answer would be this. Negative 5 plus or minus the square root of 29. That would be my answer. If I wanted an actual decimal, you would just figure that out, and you would get approximately 39 hundredths and negative and 10 and 39 hundredths if you got decimals. But I would rather have this, a simplified radical form. So the next thing is, how do I find and use max and min values by completing the square? So remember that this is what I want. This is vertex form. We're going to actually turn our examples into vertex form. Now make note. Could you do negative b over 2a and then plug that value in to find your max and min point? Absolutely. But what I'm showing you is just another way to do something if you want to do it. So step 1, this is what I would do. Since now the x squared plus 4x is on the right side, I'm going to complete the square on the right side. So I'm going to add 1 to both sides. That gives me x squared plus 4x. I now complete the square. There's nothing in front of the x squared. There's a 1 here. So that's what I want. I now take half of 4 and square it. Half of 4 squared is 4. So then I add 4 on both sides. That gives me y plus 5 equals x plus 2 squared. I now move the 5 back over. Move the 5 back over by subtracting 5. And voila, look what I have now. I have vertex form. Done. My vertex form then would be my vertex is negative 2, negative 5, which means the function has a minimum value of negative 5. Why is it not a maximum? Because right here, there's a positive, there's not a negative, so that means it opens up. Therefore, that's how I figure out if I have a minimum. So let's find a maximum value. We know this one opens down. Because it opens down, we have a max. So what I'm going to do, I'm going to make this a positive 1, which it's not. So I'm going to move these two terms to the left and the y to the right. So I'm going to get x squared minus 2x, leave a blank, equals negative y plus 7. I then complete the square. Half of negative 2 is negative 1. Squared is positive 1. That means I add 1 on both sides. I now get x minus 1 squared equals negative y plus 8. I now do the switcheroo. I move this entire thing over to the right, and I move the negative y back to the left because I want to solve for y. That gives me y equals negative x minus 1 squared plus 8. Since that's a negative, we already know it opens downward, so my vertex is 1 positive 8. Therefore, my max value is 8. So, example 6. Which of these functions could be represented by the graph? Let's look. F of x. Perfect. Opens downward. Yep, this opens downward. By the way, we have no scale. No scale at all. But we can look at the characteristics to figure out what we'd have. This opens down. However, the vertex is negative 4, 8. Negative 4, 8 would be somewhere up here. Not the first one. G of x opens downward. It's 5, 9. So could the vertex be 5, 9? Absolutely. So g of x could be our answer. The next one, instantly you see that it opens upward. Since that's positive, can't open upward. And lastly, it opens downward. Our vertex, or our intercepts are 2 and 8. So could these be 2 and 8? You better believe it. So our two answers would be functions g of x and p of x. G and p could be the functions that make this graph. Example number 7, a real-life application. The function y equals negative 16x squared plus 96x represents the height y in feet of a model rocket x seconds after it is launched. Find the maximum height of the rocket. Find and interpret the axis of symmetry. We want the maximum height, so I am going to complete the square. So that means I'm going to move the negative 16x squared plus 96x to the left side and get 16x squared plus 96x. That's not right. It'd be minus 96x, or 96x equals negative y. I then must factor out a number. So I'm going to factor out a 16. If I do that, I get x squared minus 6x equals negative y. And this is where it gets difficult. This is something new with completing the square. If I complete the square, you will take half of negative 6, which is negative 3, and that means you're going to add 9. But you are not going to add 9 to the right side because you have a 16 here. You could have divided both sides by 16 or divided everything by 16. That would work. But because this is really 16 times 9, you have to take 16 times 9 and get 144, and that's what you add to the right side. I now factor 16 times x minus 3 squared equals negative y plus 144. I do the switcheroo. I move the negative y to the left and get y. I move the 16 times x minus 3 squared to the right, and I get negative 16 times x minus 3 squared plus 144. My vertex is 3, 144. So what does that mean? That means if it's 344, the maximum value is 144, which means the rocket reaches a maximum value of 144 feet. Here's another example, example 8. You decide to use chalkboard paint to create a chalkboard on a door. You want the chalkboard to cover 6 square feet and to have a uniform border as shown. Find the width of the border to the nearest inch. Well, what you have to do, now I'm hoping you get this, that all I want to figure out what times what, base times height, gives you 6 square feet. I know that I have a chalkboard that base times height is 6 feet. But I now have to figure out what that base is. Because both sides are x, the entire thing is 3. So I would have to take the base, which is 3 minus 2x, multiplied by the height, which is 7 minus 2x, because I'm subtracting the top and bottom, which is x. We have 2 of them, so 7 minus 2x. I now have to FOIL this. That would give me 21 minus 20x plus 4x squared equals 6. If I'm going to complete the square, I have to put everything on the appropriate sides. So I would have 4x squared minus 20x. I would move the 21 to the right side. 6 minus 21 would be negative 15. I now have to divide everything by 4. If I divide everything by 4, I get x squared minus 5x equals negative 15 fourths. You have fractions to deal with. I now have to take half of 5, or negative 5. Half of negative 5 is negative 5 halves, and I square that. I get plus 25 fourths, which means I have to add 25 fourths as well to the right side. If I complete the square, which I just did, if I simplify that, that gives me x minus 5 halves squared equals, well, 25 fourths minus 15 fourths is 10 fourths. So now I take the square root of both sides. If I take the square root of both sides, this is not going to be fun. I get x minus 5 halves equals the square root of 10 over 2. I now have to add 5 halves on both sides. That gives me 5 halves plus the square root of 10 halves, or plus or minus, I should say, because that gives me plus or minus. So my final answer will be 5 plus or minus root 10, all divided by 2. And it won't let me actually write, there we go, 2. If you figure that out, it's going to give me approximately 4.08 or 0.92. Now, it's not possible for the width to be 4.08 because if each width is 4.08, well, it's already bigger than 3. So it can't be 4.08. Therefore, the width of the border is 0.92 feet. If you convert that into inches, 0.92 feet times 12 inches, it would actually be about 11 inches as the width of the border.